So as a learner, you are given f of x, and then we are going to be wide on the things that we need to know. Look, things that we have to know. Yeah. We need to know how to get the turning point, the coordinates of the turning point. We also should know how to get the equation. Well, there are two ways in which they can ask the equation. By now we know equation. So they say to us the graph of f of x is given by ax cubed plus bx plus c minus 5. And then we have the point E, which is -1 is to 0. And then we also have G, which is 5 is to 0. At the x-intercept, that being specific. Those things, they represent the what? The x-intercept. So if they represent the x-intercept, the first question says, show that A and B and show that A is 1, B is -3, and C is -9. So there's no need for us when we go to the next question not to say A is what, B is what, and C is what. Even if we cannot show them, but I expect it from you, Charlie, this one. This one is what I also expect if we are serious about getting the mark that we said we wanted to get. So what are we going to say to them? We are going to tell them we have a turning point here. What can you tell me about this value if it's a turning point? What do you know about turning points? It's going to repeat itself how many times? 2 times. So basically we are going to have y, which is going to be equal to a x minus x1, x minus x2, x minus x3, like this. And now we have y, which is going to be equal to a, and then we have x plus 1, and then we have x plus 1, and then we also have x minus 5, like this. And then from here onwards, we need another point. This time around, we are not given another point, but we can find it. How do you find it? You can tell them, what if I put 0 here and put 0 here and put 0? Now, when x is 0, what is going to be my y? Look at this. When x is equal to 0, what is my y? Yeah, the value of t is always the y-intercept. So even if they didn't show it on the graph, we should know it, that one. So you can come and say x is 0, our y is equal to what? -5. So I will take this -5 and substitute it here. I will tell them, okay, here's what I have. Remember, I have y is equal to -5, which is going to be equal to a, open bracket 0, plus 1, 0, plus 1, 0, -5. And if you do this, it says which a is going to be equal to what? To 1. You'll see, man. Actually, I'm going to say 1 multiplied by 1 multiplied by -5. And then we're going to have something like this. You have -5 is equal to -5a. You divide both sides. If you divide both sides, you are going to get what? A is equal to what? To 1. You look surprised, then. What's surprising me? You got it. Okay. So next one, what is it that we're going to do then? We're going to simply say, okay, we have y, which is going to be equal to x. We don't have to put the 1, actually it's 1. So it's x plus 1, is x plus 1, it's x minus 5. Still good. Okay, what do we have then from here? Take any two brackets. Let's start with the first two. If you take the first two, you're going to have x squared plus 2x plus 1. Close bracket, x minus 5. Now, can bring in another column so that we will remember we're multiplying. If we multiply, we're going to have this one multiplied by this one. What you get? You get x cubed. So you have x cubed, this one multiplied by this one, 2x squared. This one multiplied by this one, plus x. Can you take another column? This one multiplied by this one, minus. It's fine. It's -5. Okay. So you have minus 5x squared. This one multiplied by this one, -10. Minus 10 x. Okay, this one multiplied by this one, -5. Do you see any like terms there? Yes. Okay, what are the like terms? We have x cubed, it doesn't have a friend. X and x, they give us -3x squared. It's fine. And then this one and this one, What is this? X. 10x minus 10x and x gives us minus 9x. And this one and this, it's alone, minus 5. And then we've shown them. We've just shown them which one is A, what is B, what is C. So this one is going to give us 3 marks. And then we'll say, okay, A is equal to 1, B is equal to minus 3, and then C is equal to what? Minus 9. So what was the trick here? Is that they gave us the y-intercept indirectly. So that was the only trick there. But at least we would have gotten a mark for doing this. Substituting x1, x2, and what and x3. There's a mark for that. Okay. Calculate the values of x for which this thing here is going to have a local minimum. So they just want the x value. Local minimum, local maximum, maximize, minimize. Think of differentiation. Every time when you see the weights, maximum, minimum, stationary point, we are thinking of differentiation. So 9.2. We're going to have f prime of x. This one multiplied by this one, it gives us 3x squared. This one multiplied by this one, minus 6x. This one it gives us minus 9. Okay, 0 is equal to 3x squared minus 6x minus 9. What do you get? If you divide by 3 everywhere, you get x. You get minus 3, you get x plus 1. It says x is going to be 3. X is equal to minus 1. So which one do they want? They say they want the one which is going to give us a local minimum. Between the two of them, which one gives you the local minimum? The 1 or the 3? Which one gives you the local minimum? The 1. Are you sure? We have minus 1, and we have 3. Which one gives us the local minimum? We have here, the graph here. Is it at maximum or minimum? Here at E, let's go to E. At E, it's at maximum. So here, what are the coordinates here? It's 3 and something. So which one gives us the local minimum? We are going to tell them, therefore, x is going to be equal to what? To 3. And then differentiation, putting a 0, factorizing, and then choosing the correct one. We are going to get a mark. Are we still fine? Not fine? Yeah, you have 2 values. You have minus 1. We already knew this one was minus 1 because it's a turning point. Your graph here is at the biggest. The graph here is bigger here than here. Here it's at the local minimum. It's at the minimum value. Here it's at the maximum. Is it fine? Yeah, this one here is bigger than this one here. And then what is this value? This one is minus 1. We can't use minus 1 because it's on the. And I'm sure you also have to check which does make sense. Where is x? It's on the negative side. And then this side, x is at the what? At the positive side. So what is the positive side? It's 3. So that one is a local one minimum. Okay, then we start to go to high order questions. This one is a high order question. I wouldn't really be against you if you didn't get it, but if you got it, I will be happy. So what is it that they are looking for here? They are looking for f prime prime of x multiplied by f of x. You want f prime prime of x multiplied by f of x, and then they should give you something which is going to be actually positive. What is f prime prime of x? You differentiate for the second time. So maybe let's differentiate for the second time and see what do we get. So if we differentiate for the second time, we're going to have f prime of x prime. We are going to have this one multiplied by this one, which gives us 6x minus 6. Right? Minus 6. If you were to draw this function, how is this function going to look like? This function is going to look like this. You put 0 here. It's like a straight line. If you have a straight line, you have to draw a straight line. How will you draw the straight line? First, we are going to start by putting 0 here. If you put 0, it says which x. When x is equal to 0, our y is going to be equal to what? Minus 6. Yeah? But if you put 0 on y, you have 0, which is going to be equal to 6x minus 6. You take this one to this other side. 81 goes with what? With 1. So these are the values that you have for this thing that you can draw it. So you go there and say, okay, let me draw a rough sketch of this thing. How does it look like? So I have minus 5 here. I expect to have minus 6 somewhere here. I expect to have 1 somewhere here. And then I can simply connect these two. For you to draw a straight line, remember, you just need 2 points, right? So you have your straight line. Yeah? Now, what is it that they want? They want you to multiply f prime prime of x with f of x, and then they should give you something which is what? Which is positive. Now, how to get something which is positive? That's the question that you can ask. The only way you can get positive is if you have a positive and a positive. A positive and a positive, they're going to give you a positive. What is the other way in which you can get a positive? You can get a positive by saying a negative and a what and a negative. Now, let's talk in terms of graph. What does that mean? It means it's either you're going to have both graphs above the x-axis or you're going to have both graphs below the x-axis. Let's go and check the graphs. We want both of them to be above the x-axis or both of them to be what? To be below the x-axis. So let's check this one. This one is below the x-axis. Now you're going to make something like this. If you want to make your life a little bit simple, you say, okay, but now this one here is below the x-axis. Below the x-axis, this one is also below the x-axis. Below the x-axis, this one is also below the x-axis. Below the x-axis, this one is also below the x-axis, up until we get here. Both of them are below. Now let's check here. This one is below, this one is what is above. Below, this one is what is above. Up until I get here again. So I'm going to highlight these places here. They are very important. This thing continues, by the way, it doesn't stop there. So I need to make sure which I represent that way. So this one is going to continue. Yeah? After this line here, this one is above, this one is also what? All right. Then I can highlight these places that are both graphs are above or both graphs are below. So let's highlight this one first. With this one here, both graphs are below. And then we are going to use this. You're going to get a vertical line. That vertical line is my frame of reference. Whatever the x value is there, that's the value that I'm going to be using. So let me talk about that value. What is that value here? What is x here? It's 1. Then if I go this side, the values that are that side, are they bigger than 1 or less than 1? They're less than 1. So I will tell them which one x is less than 1. That's number 1. Again, I also have another horizontal plot here. And then I can highlight this. This I also want. This one I also want. So, yeah, you got it. I can see her laughing. She's laughing which she got it or she didn't get it. Okay, so if we go this side, values that are this side, are they bigger than? Bigger than. So we're going to say x is bigger than 1 than 5. So x is going to be less than 1 or x is going to be greater than 1 than 5. Yeah, no, let's not take this one personal. Let's not take this one personal. I should give you 3 marks. Let's go to 9.4. 9.4. On 9.4, they say for which values of t will the graph of p is equal to f of x plus 2 have 2 distinct roots, 1 negative. So guys, if you can get this question, I have money. I'll give you the money. If you got this one, if you got this one, I am going to give you money. I will definitely give you this one. Suddenly I explain it to you. We don't count you. Yes. So what do we have? We have f of x plus t. Now when they say f of x plus t, this is how I think about this question. I think about it, which is the reflection of f of x. Whatever f of x was, we are going to take the opposite of it. Whatever f of x was, we're going to reflect it. And then if we reflect it, we're going to reflect it by the x-axis. Meaning, here's what I'm going to do. With this one, if they give you about t, for which values you are going to have t, t is a y value. T represents whatever the y value is. So, what are the y values that we have? We're going to start with the minimum. Let's start with the minimum. The minimum value that we had 3, and then we just have to get what is our y there. How to get your y? You take this 3 and then you substitute it on the original equation. Can you quickly do that for me so that we know which 3 goes with who? It goes with minus 32. No? Okay, we also have another point, another stationary point. Another stationary point we have minus 1. It goes with what? With with 0. So these are the two values that we have. Okay, so what do they want? They want to have two positive roots, né? And then they want us to have two distinct, that's very important, two distinct positive roots, and then we should have one which is what? Which is negative. So what is it that they're asking here? Let me pause this, and then let me show you something here on the, yeah.